We really want to give you an update as to where the engine monitoring is, so I brought in a couple of guests.
Exit stage down.
I feel like an interviewer. Feels very odd.
So how do you feel about that?
You need to be on a couch.
Yeah, well, we do. We need to do a Graham Norton or something.
We've taken a sunken fishing trawler and converted her to a community-funded expedition and research boat crewed by volunteers from around the world.
Because life's too short not to fight for your dream. Describe your background, your skills, your qualifications.
So my background's electronic engineering, although through my career I've done lots of other things. I guess the underlying theme is around automation. So I've done a lot with industrial automation, then aerospace automation. With my more recent roles, I was running a school in engineering, so I had mechanical engineering and mechatronic engineering, electrical engineering in there. So in a way, as my career's gone on, I've sort of done more and more type things. But now, having retired, I'm really going back to the grassroots of what I like to do technically. And that's pretty much the automation that we're talking about right here.
There's a lot that's happening in the background that you won't know about. Duncan is back and forth from his home, staying for a 3-day period and working on the systems in the background, and it's monitoring systems and it's all sorts. And we wanted to give you an overview because it's kind of getting lost. There's so much happening, and Damien's done his pen drawing to provide a visual aid. It's actually quite a complex thing to conceptualize, and I think that's what's actually quite difficult. So
yeah, and I thought we could talk just a reminder as to where we got to, because I'm now trying to think back to the time when the old engine came out, because that's really the last time I really showed everyone where we were up to. And just as that reminder, you might recall we had some instrumentation in the engine room there, and actually I'm going to put up the right instrumentation now. So that's one of the little modules that we're working with, and there's another module which is still down in the engine room, and that's the NMEA 2000 box. And between the two modules, that's where we're connecting all the various engine sensors, and that's what we were doing just as we discovered there was a problem with the first engine. But just to remind you all where we got to, so we had this module, and then the NMEA 2000 module down in the engine room. It's still down there in the box that everyone keeps hitting their head on, fixing up the engine room. And then we had 2 cables running from the modules up toward the wheelhouse. At the moment, the cables are sitting in the battery bay, which is just down here. But ultimately, we need to connect them up to the wheelhouse with the rest of the instrumentation. Don't forget the termination at each end. And
What one's RS-45?
So by the magic of filmmaking, here are the 2 cables. So they're now sitting up here in the battery bay. When the new engine comes in, then we'll resume connecting the sensors. So some sensors will already been in the engine. We might have to fit some extra sensors there. And these are the sensors that then ultimately display up on the instrumentation, up on the wheelhouse there. So up in the wheelhouse, we had, you might remember that we had a single Raspberry Pi, and that single Raspberry Pi was running an instrumentation system on a monitor up in the wheelhouse, and it was also providing OpenCPN navigation charts. What we've been looking at in the background while the engine's been sorted out is we really were finding the Raspberry Pi was struggling under the load of doing both the navigation in a real-time navigation management sense and the instrumentation system itself. So what we've now just done is split the tasks and introduced a little NUC processor. So that's a commercial product. It's a Celeron-based computer. And we've now split the tasks. So the Raspberry Pi itself, it's doing the instrumentation by itself. And now this system here is running the navigation system. So these 2 will be connected via Ethernet. There's a big Ethernet network now sitting up in the wheelhouse, growing every time we add something to it. But we also will have the NMEA 2000 connection sitting up in the wheelhouse, and we connect to the NMEA 2000 bus through the Ethernet connection at the end there. So with these 2 buses coming up, we'll continue those up onto the wheelhouse. We then have this little interface which connects onto the Ethernet itself. And so these 2 computers will have both Ethernet connections with them talking plus a number of other devices sitting up there. One of the other devices that we need to talk to is our AIS transponder. So eventually when this boat gets registered, we'll get an MMSI number for that, and we'll program the AIS transponder with that. It needs to connect to a VHF antenna up on the wheelhouse roof there, and then it connects to the, actually I think it's there, the NMEA 2000 port sitting right there. The added bonus is this also has a GPS antenna, so it can feed GPS into the system, which means now we've got redundant GPS. We've got our current GPS system, which is coming in through the North Star system, and we've got this one here, which provides us a backup. And that was a very important thing. We want as much redundancy, as much reliability as we can possibly get. Other things that are happening as we speak, we're actually also testing. It's probably an interim video monitoring system. So the idea is there will be cameras around the boat, primarily for safety reasons. And just today we're talking about the sort of camera we might put up on the bow of the boat looking forward, and that would involve infrared, for instance, looking forward for all sorts of things. It could be ice, it could be whale, whatever, anything above surface we could have a look at. So cameras around the outside. Damien some time ago had bought an analogue camera kit with a PVR to record CCTV. So we're just having a look at that right now. And it looks like we can talk to it over the network. So we're just, as we're almost speaking, trying to connect it into the system. The whole idea is that with the Raspberry Pi, it's really becoming the data hub. So the data's coming in from all sorts of directions on the boat, and then it's becoming the hub to process and then forward data where it needs to. Apart from all the engine data that comes in, have the CCTV data coming in, got fire systems. We've got Jason here right now, and I know he spent a lot of time talking to Jess and Damien about the fire systems. I'd like to have a chat to him later on today about that. The electrical systems, so you'll have seen in the past that the boat's being wired with 240 volt circuits. So the idea is for each circuit we want to monitor the performance of each of those circuits, and we may have to look at automatic switching at some point, for instance hot water service. And the other is if we need to load shed, we've got a good handle on what current is fronting which circuit. So I guess we could think about the engine monitoring as being a small part of all the things that are being monitored up in the wheelhouse there. We need to bring in the depth sounder as well. So not only how the engine's performing, but clearly the depth below the hull or the keel, either way, we can set which one we want there. So we need to bring that up to the wheelhouse. The status of the vessel overall, we've got two bilge points that we want to look at. In fact, I'm going to go there because it's roughly where they are there. We've got cabins down there. There are cabins, and we're in one of them now up here. Of course, with the engine room, and it's not just fire we're concerned with there, even just heat. We'd like to know of any abnormal heat build-up within the engine room. So we're looking at several methods that we can do that. And then we've got our fuel tanks and our freshwater tanks. We've got more tanks over there. So monitoring the levels of those. And one of our big challenges right now is very, very keen to look at the instantaneous or near instantaneous fuel consumption of the engine. And so there is a day tank, well, it used to be there. I don't know where it's going to go with the new motor, but a day tank which basically is filled up with fuel for the day, and then we can monitor the level of that over hours, so we can get a fuel burn on an hourly basis. It would be ultimately very nice to get a minute-by-minute fuel burn, and that way, as fuel type is trialled, as the wings are deployed with the boat, we can look at the performance of the engine and the craft itself. The best results will be if we can measure fuel in terms of litres per minute. It's pretty much instantaneous. Those sensors cost a lot of money, so at the moment we're going to just do it by the day tank, and that'll give us a fuel burn by hours rather than minutes, but it's a starting point.
And remember, we're going to be comparing diesel with vegetable oil, and how efficient it is. Try and think of Brupeg as every inch is pretty much going to be monitored. We want to know everything. And if you're new to Damien, you'll notice that he's already considering additions. There's an extension on the end. And so we're just going to ignore them for now.
So I think a point I've heard both Jess and Damien mention in the past is really having data drive all the decisions that are made and the analysis that are made. So whatever concept or performance aspect is being tested out, the fact we've got data underpinning that, and so we know how things are going to perform.
Exactly.
If you're wondering, Damien's sitting right down here directing the whole show. Your goal is research, so the boat undertaking research tasks. But the fact you've got volunteers and of course yourselves on board, so you've got pretty precious crew and cargo.
Yeah.
on board there. So we need to be as safe as possible.
There'll be nothing we don't know about.
Everything will be monitored. To an extent, we need to provide some privacy.
Bathroom.
Yes, a few no-go zones.
You know, everyone will have their space as we're doing projects and travelling and even resting.
Well, it just reminded me that my hammock is right there.
Oh, that's right.
Yeah, so my hammock gets installed there. Yep.
Sofa, what do you want? Potato gun.
Working on.
Amazing.
So we'll have a chat to Jason actually straight after doing this.
As you can tell, there's a lot to do.
Lot to do.
There's a lot of manuals to be written, a lot of procedures to be organised and honed.
Actually, that's a very good point. This is something we started doing in the background. We've got a lot more to do on this, and that is standard operating procedures, or SOPs. What Jason's coming up with the fire response or risk management plan. Then there'll be SOPs and training, which then goes in with the SOPs. So we're already talking about inductions for people, obviously for fire response inductions. Anyone involved in the wheelhouse, there'll need to be inductions for that. There'll be washing dishes inductions. Definitely. Where things go.
There's a lot of discussion around Dutch.
We need to make sure the steak knives go in the right spot. It's never going to live it down. Nor am I.
Damien was so disappointed.
He was. I failed him. I failed Damien. I'm surprised I'm still on the boat.
We all have our little things around the boat. It's got to be organised. Everyone has their thing. It's really funny.
And I guess a lot of it is going to be invisibles. So if this is all operating as it should be, it all becomes seamless, it all becomes smooth, it all becomes safer.
We'll be able to react really fast if there's a problem, and hopefully we'll all, after Jason's trained us up, we'll be able to respond really well to any fires or any issues.
Well, we're probably, a few weeks off a lot of this happening down here, so the new engine, or new old engine arriving. They get the get home motors sitting ready to go in.
Gearboxes here.
So a few weeks it's all going to be happening down here. I'll be continuing with the wheelhouse and the data systems up this way, and when this is all settled in and it's safe enough to walk around down there, we'll get the instrumentation basically pick up where we were before the original engine fell over.
And all the hardware's still there, you can just...
Yeah, that's the box that's hanging down. I'm surprised that hasn't been taken out, to be honest. And the other thing that we haven't got back to is the lightning protection system.
Oh, yeah.
Which really we need all of this done first.
Yeah.
But we need to get onto the lightning protection system. So we've done some original work on that.
Thanks, Graham.
Thanks, Graham.
Duncan and Graham have put together, based on research, based on actual understanding and experience in the field, what is the best thing for lightning protection for a boat like this. So we'll talk about that, we'll cover that a bit later, but it's very thorough. So it's because there's a lot of opinions, a lot of ideas out there in the world, and what we discovered was there was nothing reliable. So
we've got some systems in mind on how to do that, because the last thing we want are radios to be blown up at sea. A big thank you to Duncan for creating this amazing monitoring and navigation system, all the parts you've donated, all the time, trips up. It's been great fun. Excellent. Maybe. Can I leave that last one in? No. That was very good. Okay, so this is the engine monitoring system, and you've seen snippets of this in the past. We still have the North Star system here, so the North Star system is providing GPS data, and the fact that GPS is true, that's why we've got a green symbol there, and the status for the NMEA from the North Star, that's green. We also have a database for the data logging. That's all in good condition. We've got local area network, we've got wide area network. The critical gauges here being the engine tachometer, speed over ground, course over ground. You can see course over ground is live. Speed over ground, the boat's not working, or not moving, so we've got 0 knots, which makes a lot of sense. You'll see occasionally it's saying that the nav data is stale. So the system is monitoring the critical elements of data, and where there hasn't been a change for, I think it's about 10 seconds, it's indicating that. So that means the skipper at the time, if he or she is not getting an update with any one of these gauges, a little purple spinning wheel like this appears, and that's to say, do not trust this data, and then hopefully it refreshes in due course. Here's where the depth transducer will feed in, so we're looking at below below transom in this particular case, but we can set it to whatever Damien and Jess would prefer there. This row here, we're talking about critical data for the engine. Now we'll revise some of this stuff now with the new engine coming in, and some of the priorities might change. And probably two of the trickiest sensors we've got to deal with exhaust gas temperature, and we've got the sensors for it. Just needs to be a little bit of interfacing there, and then the manifold pressure. Again, just a little bit of interfacing required there. So we've got a range of other sensors here and other elements of data. We'll probably change a lot of these things. Again, they're evolving. So for instance, the starting battery will become meaningless with the new engine, simply because it'll be an air start. So maybe we'll be looking at air pressure here. So these will change over time. It's very easy to adapt the screen. The video thumbnails. So when we have the video system and cameras hooked up, these little traffic cams will be replaced. These are just publicly available traffic cams I use for testing purposes. When we hook up the cameras, then we'll see those thumbnails there, and then we've got a dedicated page where we can have a look at all of the, whatever cameras are coming in, we can look at all of the images in more detail there. We've got placeholders at the moment for the electrical system, the fire panel, and then some diagnostics. So the performance of the processor, we just want to make sure it's not getting too hot, it's not being overstressed, and ultimately also the propulsion systems. So we'll dig into a bit more detail. So as we saw earlier, we've now dedicated a NUC processor. So this is a little, I don't know how to pronounce it, melee, whatever, it's a Celeron based computer, and we've dedicated that to the navigation system. So we're doing that because unfortunately we can't get new maps for the North Star system. So we're running OpenCPN, and the idea is that we can use the features of OpenCPN. For instance, we can split screen, and I've just got set it up for a wide view or a close view. And you can see, and this is what we wanted to achieve, was to get near real-time response from that. So it does all the things OpenCPN normally does. You can see up here, then we've got our GPS is live. It's pinpointing the boat as it should. We don't have any bearing information. I can force the bearing information, but we're not really tracking anywhere. We're sitting still, so that's why you'll see the boat just spinning around for the time being. One of the things we've been working on is getting the radar going. The radar has been going previously on the North Star system. We've now tied it into OpenCPN, and you may just have heard the radar fire up. So we've transferred OpenCPN onto this NUC processor box, and this is dedicated now to the navigation system. The North Star system, unfortunately, we don't have access to any updated charts. So we've opted to move the navigation part to OpenCPN, and the thing we've been doing lately is integrating the radar, so the North Star radar, across to OpenCPN. So you can actually see there's now a thumbnail of the radar running. That's raw data, so that's not taking into account the bearing of the craft right now. The way we're doing this is for anyone who's into Signal K. Signal K is an open source maritime, I'm going to say data management system or data hub system. So we run Signal K on both systems here. So the engine monitoring computer, that's running Signal K, and it's collecting all the data. It's publishing that data on Signal K. Over on the OpenCPN system, it's mirroring that data on its own Signal K. So everything on that monitoring system is shared with OpenCPN over here. So I am artificially telling OpenCPN that this Brupeg is currently pointing 225 degrees, which is pretty close to what it's doing. And we shall turn on the overlay. So on the right hand side here, we've got the raw radar data without knowledge of where Brupeg is pointing, and that pretty much mirrors what's on the North Star system. On the left hand side, you can see the image is building up with the radar data. We've just gone through, we think, 7 days of continual rain, and you can certainly see the rain on these charts here. You can see also that we've clearly got some fine tuning to do, so we've got some radials here appearing on the images. So there are lots of parameters to tune and probably really not much point doing that until Brupeg's in the water and we can really tune this up. As we looked at earlier, we've got a lot of artefacts from buildings just around the boatyard here, so storage sheds and so forth. And then we've got the river along here, and a bit hard to see, but there's actually a pond of water behind the river, and that's been picked up by the radar as well. One of the reasons we switched across to a dedicated computer for OpenCPN is the fact that we can get a far more spontaneous response. So this is me zooming in with the mouse wheel, and you can see the response as I pan and zoom is much, much greater, and we can do the same on the left-hand side here. We can zoom in and out. We've also got access to the normal OpenCPN features, so we've got weather charts that we can bring up. I've got a watchdog which I'm implementing as well, so really all to detect that the system is working as it should be. With
Jason doing all the fire system and helping us do all the protocols and everything, and Duncan doing the monitoring, there's got to be an overlap. So this is the first conversation about that. How does it cross over? Like, what point does the monitoring come into the system?
I think we've planned what the CO2 system looks like, and basically I've done a drawing for that. Sort of copied off another boat, but shrunk down for Brupeg. We'll come about that. So for you, for the monitoring, the stuff we've come up with is we're looking at cameras in the engine bay.
Yep.
I think the cameras will be there for a visual look, not just to see if there's fire. If there's an alarm, the person in the bridge can look at the camera and go, oh look, I can actually see fire or smoke.
Yes.
So we chose 2 cameras because if you put one up in the top corner and there is a fire, smoke and heat rises, and you look at that one camera and go, oh, it's dirty.
Yeah.
Oh, hang on a second, it's probably smoke.
Yep.
So we looked at possibly putting one up high for general viewing of the engine bay.
Yep.
And also one sort of mid-level.
Yes.
So that if there is smoke and stuff happening, you can actually see it through that camera.
Correlation.
And then also having we looked at infrared camera, but I think some sort of thermal camera. So then we looked at the detectors for the boat, and I put in their zones.
Yes.
And a manual activation in each zone.
Yes.
So
The fire suppression system on Brupeg is a big topic, and Jason was so awesome in helping us sort that out. Duncan and Jason went on to talk about quite a bit about the monitoring system and what's needed. But the fire suppression system has its own episode, and that'll come out soon. We talked about all sorts of things, including how do you bug out if you're in icy waters, how do you stay safe, all of that, but more on that later.
Making me nervous. We're starting to develop SOPs and that sort of thing.
yeah, cool.
Thank you, Jason, for all your knowledge and patience and work. You're just amazing.
The big round thing down the end of the road, what are they? Well, they're actually cofferdams. So they're obviously going to do some sort of major engineering work around here, and they need to excavate and make a foundation for something fairly substantial. So these big sheets of steel that you can see in a ring here are essentially hammered down into the ground, so they create a barrier so that nothing will cave in, and they can also pump any water out that may be inside when they dig a big hole in the middle of them. So on the left you can see one that's been finished, and then on the right you can see one that they're starting the process again. So they make a ring at the top and a ring at the bottom, and then that allows them to line up these panels on the sides. The panels basically interlock and they run all the way around the circumference of this big structure. And then the cranes that you can see in the background, the red and the blue crane, they have essentially a big hammer attachment, and that comes down and starts hammering these piles or sheets into the ground. And as they go down into the ground, that top structure goes down with it, so it keeps them level and true and lovely, and it basically allows them to create what's behind this structure here with that circle pushed into the ground. What are they for? We have absolutely no idea. We've looked at the drawings and things for the public plans and so on for this, and nothing looks like what they're building, so we still are completely in the dark as to what these are. We thought they were going to be a crane mount when there was one, now there's two, but wait, there's more. Turns out they're building three, not two, and there's space over the back for a fourth one. I reckon they're going to put another one in. They're getting pretty fast at putting these things in. The first one took them a while, second one took them maybe a week or so, the third one's just about done.
Damien's on a crusade to get fitter and lose some weight. He's got a lot of physical strength but not a lot of aerobic fitness. Once we start getting into some projects, he's going to need that fitness. Everyone on board will. What you might not know is both Birk and Dame are sailors. Birk found this really cheap laser in the local marketplace online. Though Dame's taking it really seriously. He's kayaking, he's sailing, he's stretching, he's running, he's cycling, he's doing lots of varied activities to get fit in his spare time when he's got a day off.
We all strive to be more. We all long for viva la vida. Around the corner I'll meet ya, a bit lighter and freer. I'm so happy to see ya. The air fills up my lungs and it tickles. Oh, what a joyful feeling. I think I'm gonna stay here under all these rays and soak up the sun. Ooh, we long for viva la vida. Around the corner I'll meet ya, a bit lighter and freer. I'm so happy to see ya. And we learn from our mistakes, and we grow from what breaks us. We let it take its time. We long for viva la vida. Around the corner I'll meet ya, a bit lighter and freer. I'm so happy to see ya. Viva la vida. Around the corner I'll meet ya. Viva la vida. A bit lighter and freer. I'm so happy to see ya.
Well, Birk's in the engine room sanding, ready for the tanks to install. I'm going to get this thing going, but the reason I'm showing you this, normally I'd just buzz this out and it probably wouldn't even make it to camera, but I want to show you why I'm attacking this today. We've got two new machines I want to just show you. This is the plasma I introduced you to last week, the one that has its own air compressor inside it, which is bloody amazing little machine so far. And this is the Unimig Razor that we've got. This is a 230 amp welder, but it's an AC/DC, so it means that we can do TIG welding aluminium. This is the first time I've ever turned it on. I don't think my power cord's plugged in. Oh, it's going to the wrong machine. Oh, there we go, I haven't even taken the plastic off. Let's do that. I know, I'm sorry. Yeah, I know, I don't. Thank you. All right. So it has a USB port, so you can do like software upgrades and things like that to it. You can actually talk to the machine. This is pretty cool. A lot of the older, earlier machines, I don't necessarily know if you can do that. You couldn't do it with our old one. It has all sorts of functions. It's got essentially like a quick weld function, so you can select what you're doing. So rather than having to have the knowledge in your head where you know, okay, I need so many amps, so many volts, you know, all that sort of stuff as you're doing various processes, this one you can tell it what your material thickness is, what you're doing, like vertical up, vertical down, horizontal, that sort of thing, the type of wire you're using, the type of material you're welding, etc. And it'll set it all up for you. So I haven't used that function yet. I've got to get my head around how to, it's literally the first time I've opened this machine up, so I've got to get my head around how to use this. But I'm really excited because this thing can do some amazing stuff that our old machine couldn't do. So I'm really looking forward to couple of jobs we've got coming up. So I've got to fix this bow, and that's what I'm using today. We're going to be doing flux core welding with it. So that's flux core wire with a gas. And then I've also going to do flux core wire on the hatch on the deck. We're going to get that done as well. And then I'm moving over to TIG, but I've got to learn how to do AC aluminium TIG. I've never done AC aluminium TIG in my life. So I've got to figure out how to do that because I want to fix the dinghy, which is sitting just behind me. There's a few pinholes and things in there that you may have seen from a previous episode. Want to go through and clean all of that up. I have been trying to do it with an aluminium spool gun. And our spool gun was just, it's great for heavy metal, like 6mm, 8mm, that sort of thing, but it's just no good for thin stuff, and it's 2mm, so we just kept blowing holes. So really looking forward to being able to TIG it. You got so much more control with TIG. And that's one thing that I was really keen on with this machine, was the fact that it can do all of these processes. So it means that we can actually take the total number of welders on the boat down. So at the moment we've got 3 TIG welders and one we've got 3 TIG welders, all of them are capable of doing TIG and stick, and then we've got one multi-process which will do MIG as well. So there's just a lot of gear sitting in the engine room that doesn't need to be there. With this welder, we can chop it down to 1 main welder and 1 spare. The 2 welders we're going to be taking with us when we're off on journeys in Brupeg is this awesome little high-frequency SIG weld, TIG and stick welder that was donated by Nathan. Awesome little machine, really capable DC TIG and stick, and our new Unimig 230 amp AC DC MIG, TIG and stick welder. So we end up not having to just carry so much stuff around in the engine room. We're running out of space, and this is one of the ways we're going to solve that problem. You'll notice I'm sporting the latest in plasma cutting safety gear. There we go, ground up, ready to party. So 45 degree all the way around here. Nice radiuses in the corners. That's the floor of the anchor room, and then you can see this weird little piece of vertical and then angled metal that they welded in the front. Don't know why. It had a hole up here and they'd filled it up with spray foam, and it was just a rubbish repair. We're going to do a proper job of it, so we're going to be welding in steel all the way around here. I'll go on the inside and I'll weld this up along here onto the plate, and then we'll fill this with rust kill and epoxy to nuke what's currently there, and then to fill it up with a hard solid structure using epoxy. I physically can't get in to weld this. The proper repair would be basically re-engineering this and extending the crash bulkhead up and putting a plate going vertical all the way up here. That's not happening. This repair will last a long time, but yeah, that's something that Unfortunately, we're not going to be able to change the way that we can do it, and it's going to be a repair that'll outlast the length of time we have the boat. It's one of those things you have to make a call on in terms of, you know, where the priorities for the boat and the project lie. This repair that I'm going to do will last 10, 15, possibly 20 years. You could fix it better and it would last indefinitely, 50 or 100 years, but it's kind of overkill and it's not needed. We need to get the boat in the water, so a 10 or a 15 year repair, more than enough. Just because we can do the 100-year repair doesn't mean we should. And 20 minutes later, that's it welded in. Hey?
It'll be about 6 months
Yeah?
since they had
After 3 days of systems and a lot of humidity, the guys took to the water.
Waste no time, love. I'll come straight to you. All the river's wide, dear, and the road is muddy. Even if I gotta swim there, you know I'll be there soon. I love you like a garden underneath the rainfall, cooling off a heat wave in the summertime. Are you the kind of woman a man can get used to? I'm the kind of man that I wanna make it mine. If you ever need me, honey, just call me. I'll waste no time, love, I come straight to you. Oh, the river's wide, dear, and the road is muddy. Even if I gotta swim there, you know I'll be there soon. If you would've told me your mama was coming, I would've worn my finest clothes. I'm just a poor boy, I ain't got nothing, but I got love, babe, for you I know. So if you ever need me, honey, just call me. I waste no time, man, I come straight to you. All the river's wide, dear, and the road is muddy. Even if I gotta swim there, you know I'll be there